This is part 2 of our sampler Loopstation project. And in our first part, we just got as far as doing some whole bunch of math and also calculations, but also getting a indexer for our, which is going to be eminently useful in our project. And you'll just take my word for that for now. But basically, we just got a little counter to count from 0 to 1 at an audio rate. And it's going to be quite useful. Now let's start the audio bit that's going to allow us to do just like a real-time recording, a triggered recording. All right. And basically the UGen we're going to use for this is buff write, WR. Okay. So if we just go ahead and look that up, you'll see here there's some examples. And it's looking for an input array, which is just sort of a fancy way of saying it's looking for some kind of input. A buffer number. So when it says buffer number, this is the buffer it's going to write to. So we have to create a buffer, which then whatever we input, it's going to be recorded to that. This phase, as we discussed in the first part, is the indexer. So this phase will be a continuously moving number or signal that basically will write into that sample. So, it'll write to sample 1, sample 2, sample 3 at each sample. So as we record, it's writing into that sample of the buffer, or that slot of the buffer. All right. So yeah. So it's just like any sort of digital recording, you're taking little snapshots along the way, right? So this thing, whatever it is, will tell you where to place that snapshot. All right, and then you have a loop. Okay, so if we look at some of these things, there's a number of this math type of stuff that we calculated before in our first part. All right, so let's get started with the synth which is the basic syntax. And we'll call this, what do I call this? Buff rec. Okay, and let's go ahead and put our first oh, that's weird. I don't even have an out. All right, okay, buff write. You don't need an out because it's just gonna actually write. So write to a buffer, right? So we're just gonna start with a buff write object. buf wr.ar, and let's see what it looks for. So for input array, we'll just call that in for now. That'll be a variable. Buff number, we'll call buff. Okay, and then phase, we'll just say idx for index. Okay, so we've got to create those as we go. So let's make some vars, in, buff, and idx. Okay, and then we'll define those as we go. So our in is going to equal, we're recording from the mic, so we're going to do sound in .ar. Okay, now this UGen allows us to record from whatever audio hardware we have connected up to our computer. Whatever, so like in the Mac system preferences sound where it says input, that will be whatever devices there are. So I'll have like an 8-channel sound card with 8 ins or whatever. Those will be 1 through 8. 0 through 7, will be the 8 channels in, et cetera, et cetera. So sound in allows us to just access directly the buses that are coming in. So in this case, we can hard code it to 0, or we can make a variable that says, in, if we want to record from more than one mic. So here I have in ch, right? So let's go ahead and do that. We'll have a argument that says INCH, but we'll INCH, ICH, in channel, and we'll make that equal to, as a default, to 0. Okay, so that means by default we're recording to mic 1, whatever we have plugged into the first input on our sound card, whatever sound device it is. We might just be using our local sort of, the little green plug that comes in or whatever color it is into our PC. Okay, so in channel, now we need our buffer is going to be actually not an argument, not a variable, but an argument, because we have to set that on the fly. And that's the buffer we're writing to. Okay, so buf, and we don't know what that's going to be until we instantiate it, with a synth. Okay, and Then we also need a index IDX, which will be, a variable there. Okay, so this is the trickier bit. Let's go back to just briefly back to the examples here. I wonder if we can make these bigger as well. Make this bigger? No. Oops. Oh, it makes it smaller, but it doesn't make it bigger. That's interesting. Oh, interesting. I can make it smaller, but not bigger. Okay, whatever. Maybe if I close this and then reopen it. Any case, no, what I was going to show you is buffer write. Usually the example has a phaser in there, okay? But in this case, we have this independent indexer. And, at the end, by sort of more towards the end of the project, you'll see how this benefits to sync and everything like that. I think it's kind of a nice idea, but it's a bit abstract right now. So we'll just have to suspend that for now to sort of deal with the uncomfortable abstractness of it until we can get something more practical to show you what that does. But in this case, it is a bit practical because we're going to stick the index right in. Okay. So what I am going to do is I'm going to pull that index from a bus. So remember we sent this out, indexer, out to an audio bus here. We created this private audio bus. Okay. That's so that we can grab that information from other synths. So we need to grab that from a index, and we're going to call it right. So our index, our IDX, then will be equal to. So now notice that I'm using in instead of sound in. So in takes from any audio bus, and it's just a numbering sort of indexing system. So don't worry about it too much because sometimes the first sort of live channel coming in from a microphone is not zero, bus zero, but it's sometimes I think it could be like after all the outputs. However it is, sound in allows you to grab bus zero, the first one. In will allow you to grab whatever, just normal indexing system. So we're going to grab that in from, what do I call it? I call it the IDX bus, okay? So we're going to have another argument here called IDX bus. So this will be the bus that contains our indexing information. So basically that contains the phaser, but now we're just once removed. We're taking that phaser signal, we're creating it in an independent synth that's sending it out to this bus, and then we're taking the record and we're pulling it in from that bus, okay? And again, we'll go over it again, but this is why it's important, these groups, to set those as different groups. But we'll go over that again. So what we're taking that in from the IDX bus. And we don't know which that is until we actually send one, all right? So then, and we have everything. Oh, and then the envelope. Okay, so IDX bus in channel, that should be, okay. Now, in order for us to have like a nice sort of smooth transition, so when we want to be able to, and also we want to be able to turn on and off recording, of course, right? So we don't want it just to be recording all the time. We want to turn it on and then turn it off. And maybe the easiest way to do that really is to use an envelope. That'll also allow us to sort of to gently smooth into the recording so you don't get clicks and then, tail out a little bit. Okay, so we'll create an envelope here. And we'll make a simple envelope. Now we're going to make a sustained shape, and if you recall, sustained shape allows us to send it one trigger that will open up the envelope and then sustain it open, and then an off trigger that will then release that envelope and then turn it off. Okay, so we need to send two messages, sort of like a keyboard. Once you hit the key, it turns on the thing and it sustains the envelope up where it is, and then when you let go of the key, then that's a different message that releases that envelope. Okay, so we're going to use a simple one called, well, we have to have an envelope generator, env gen. That's the actual generating ugen. And then we need an envelope, and we'll just use the one ASR. Okay, and then we're just going to hard code all these values because we don't necessarily need to mess with it. And you can just change the synth def. I think that's the easiest way to go instead of having too many arguments. And is that the way I do it? Yeah, except I have a gate argument. Okay, so we're going to keep most of the things. We're going to keep the attack time. We'll just make it a quick attack. going to keep the sustain level and maybe just change the release time. So I just jump to that argument, and we're going to make that pretty abrupt too. 10 milliseconds, fine. And then curve, we'll change that as well to 0. We'll just make it a linear envelope. Okay, and then, so we got the envelope shape. Now we're back into the omgen, ugen, and we just need this gate argument. Okay, so we're going to have gate, the argument of gate. So we'll put that there. And we'll set the default to 0, meaning that when we instantiate this synth, when we make a synth based on that synth def, it won't start recording right away. You know, we have to give it a gate 1 before it starts recording. Can I believe I keep that just a normal? That's right, okay. And then the thing I forget to do all the time is to actually use the envelope. So we simply just are going to multiply our in signal by the envelope. So when envelope is 0, when it's closed, nothing's coming in. And then when envelope is open up to 1, it's being multiplied by the in, and it's being written to our buffer. Okay. So I think I just caught something that I shouldn't do. Technically, I think it's always writing, even though the envelope's down. So maybe ideally we'd start it and then release it and then kill it every time. That might be a way to do it. I think that might be a smarter way to do this. Okay, so I'm talking to myself, okay, but that just means that I'm trying to figure something out. And I think maybe in my original plan here, I'll explain, is that I basically send this going, I think, in group, and then I send these going. Yeah, I send a bunch of synths going, record synths. I have 8 of them, I think, and they're running. So, but maybe it's more efficient, really, to not have them running, but to have my OSC message come in. Don't worry about this yet. We'll get to it. But have the message that comes actually start a brand new synth. And it makes more sense because, in fact, even though envelope is 0, it's still running. It's still writing to that. It's just writing 0 every time to that buffer. So instead of doing that and having some additional problems, maybe we'll just make it so that we start a new record and then we kill it when we release it. Okay, and we just have to make sure that everything is copacetic there. All right, so in order how to do that, we're then just going to use this thing. Actually, I don't think I've covered this in any of my tutorials yet, is this done action. Okay, so envelope generator, we're not dealing with the envelope in here. We have that envelope. So there's a number of arguments in the envelope generator. One is the gate, which is the one we use all the time. All right, and then another one is this done action at the very end. So done action is mean when the envelope is done running, it's going to perform an action. Okay, so done action number 2 is in fact the action of killing the synth. So basically, when I send the synth, it's going to record. When I send a gate 1, it's going to record. So we'll actually make that gate 1. So as soon as I instantiate the synth, it starts recording, depending on whatever information I give it. And then when I release it, when I set gate to 0, it kills it. So it's gone. It's gone away. All right. So we'll just use it, sort of build it on the fly. Hopefully that was a little bit clear. It'll become more clear as the more you get used to this stuff. Okay. Save that. All right. So I think that's there. So envelope, and we're going to multiply that by the envelope. That's pretty much it. So this is a useful recording device, with the only sort of innovation being that we're having a external indexing, so we can do this kind of sync business. Okay, so now just remember, we also need to think about, we're switching gears a little bit, and we're going to think a little bit about order of execution in terms of data, in terms of the way the computer thinks, and not so much in terms of audio. And so in order to do that, we're going to have to use this group system. And that just ensures that groups are being executed in a certain order, or certain processes are being executed in a certain order. Now, we want our indexes to be running first before we start recording, because the record ones are going to use this index as to where to write into their thing. Okay, so that's one thing we have to shore up, and we'll call this rec group. What did I call it? I called it the in group. Okay, so in. And then instead of saying new, what we're going to say is we're going to say after certain things. So just whatever happens in the in group happens after the IX group. So instead of new, we're going to say after. So it's going to create a group that is running after, and then I'm going to say IX group. So it kind of goes without saying that when I evaluate these things, I have to evaluate that first and that first. Or, if I evaluate all this together, it's just going to take things one after another. Okay. Now, the other thing too, and this will kind of change eventually, but the other thing too, because we're going to create several tracks, but let's just do one track at a time. I'll show you how to multiply these. That gets a little bit complicated, but so let's just sort of stay focused on one thing at a time. Is we're going to create a set of buffer, just a buffer for it to come into. So we'll call this SND buff. I think I call it something else here. What did I call it? Synths. Tracks. I call them tracks. Okay, well, we'll call it sound buff for now. Okay, and we're gonna make a buffer .alloc allocate a buffer, and it's gonna go to the server, and the number of frames is gonna be the same. So we'll just use this. Actually, we could have just copied and pasted that. S.sample rate. Okay, so we're gonna have a buffer this long. It's gonna be the sample rate, which is the number of samples per second, times the total number of seconds, right? Which in the previous tutorial we calculated here based on a beats per minute. So, we can change tempos and stuff and have all that update, okay? So it's exactly the same. We're allocating another buffer exactly the same as the index buff, which makes sense because our index buff is going to be running through a buffer that's the same size as the sounds we record, all right? So now when we start, let's make a B. When we start the synth, we're going to make a synth. Okay, and then it's going to be based on the synth buff record. And then we're going to have a load of arguments in these brackets. So one of them is going to be buff, that one right there. And what one are we going to use? We're going to use this one we just created, the sound buff. So tilde sound buff, once I execute that line, becomes this buffer. Okay, so we're going to use that buffer. Okay, and then we're going to write out to we're going to use as an index buff, right? The index bus, the IDX bus is going to be this one that we wrote out to with our buffer index. So our index is writing out to this bus, right? IXA bus, the index audio bus. So this IDX bus will be this IXA bus. Yeah. All right, and our gate is already preset to 1, so that should be okay. And I think that's it. So that's going to record there. Okay, and that's going to set it to record. And then once we hit, oops, sorry, there is one more thing, one more argument in the synth. And that, remember, is that target argument. That means that this is the data portion, the programming, the computer portion of it. So we want that target to be that group, which is, I believe it was called INGR, in group. Okay, then we can close off our synth. Group then is going to run after the index group. So the indexes are going because we need to use the index here. Okay, and that's just an order of operations. All right, and in order to stop recording, we're going to do b.set, and we're going to set that gate, to 0. Okay, and then because we have a done action 2, it'll release it in 10 milliseconds, and then it'll just kill the synth altogether. All right, so let's go ahead and recompile and then boot, and then I'll send all this information all the way down to my 2 synth defs. Okay, that seems to work. I'll start my index synth, so the index is running now, and it's continuously running now, sending that phaser information to that bus, which is the IXA bus, this audio bus. So in fact, I don't think you can I can try, but I don't think it works. Sorry, this is a IXA bus. I think you can do .get, and get a value, but I have a feeling with audio buses it doesn't work. Yeah, it's always 0. It's kind of a different too fast or different rate. Okay, so so it's actually recording now. Oh no, did we send this yet? Not yet. Okay, so if we record, la 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 la, and record some more, and record some more, and record, and then we cut it off, it should go away. Okay, so let me show you. Let me just get this ready, just for an example. If I do s.query all nodes, this will just tell me what kind of things are running at any given time. So if I do it now, I should just see my index thing. I have the 2 groups, and then the buff index is running, right? That's my indexer. If I start recording, record. If I query, you'll see that buff record is also there in the second group. So the buff index is running first and the buff record. If I shut it off, you'll see what done action 2 does. You'll notice that it's gone now. Okay. So how do we tell? Well, let's just go to the, hopefully my thing grows back. The buffer write. Ooh. I don't know how this works. Oh well. View enlarge font. Ugh. So there's a problem, I think, with the. I'll probably have to quit and rerun. Anyways, let's just grab this buffer read here, and just see if it's there, just for testing purposes. Oops. Okay, buffer rate 1, phaser, buffer rate scale, blah blah blah. Buffer rate frames. Where's it getting its? All right, 0 is the 1. So it says buff number 0. So we actually want sound buff. Okay, copy paste that. So it's gonna go phaser 0. What's 0? Trig right. Start. That's the buffer times rate. That's that. Okay, that should do it. And let's see. Let's not make myself too loud now. Is my sound set up correctly? Hopefully it is. I think it is. Output set to line out. Yeah. Okay. Okay. Well, let's see what that does. Record. If I shut it off. Record. La 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 la. Start recording. Record. If I query, you'll see that's buffer. Okay. Well, there you go. So it works. So you see that it wrote the buffer. Okay. Well, wasn't too bad, I guess. Hopefully, I didn't go too fast. I'll just review really quickly. So in that tutorial, we just built a buff record. For our looper, we're going to have live recording. So just basically a live recorder, and we have the ability to turn it on and off. So what I had to do was I built the synth def. Let's make this a little bit smaller so we can see everything on one line. And, I created this buffer write thing. And I have an in, which is a sound in coming from channel 1, my mic. I have a buffer to write to. And then I have this index, which normally is some kind of phaser. It's some kind of signal that gradually goes from 0 to 1 over the length of the buffer. If it's a 2-second buffer, then it'll go to 0 to 1 in 2 seconds. If I wanted to go 0 to 1 in 1 second, it'll just sound twice as fast, etc., etc. But the difference is, instead of having a phaser here, within the synth def, I'm going to have an external index here that's being written out to a bus. Okay, an audio bus. So it's just like a patch bay, an audio bus. So it's just like I have this, this computer going 1, 2, 3, 4, 5, whatever, or 0, 0.1, 0.2 exactly. And it's just saying that. And then I just patch that into through this bus. It's going out to a bus. And if I patch that bus into my buff record, I bring it in here in this in. It's an audio signal, even though it's just an index. It's an audio signal. And it's coming in, or audio rate signal, I should say. And it's coming in, and it's just like if I put phaser in there. It's just being read from this bus. All right. And then I set the synth up to run. So I run my index synth, which was the last tutorial. Then I run my record synth if I want to record. Okay. And we mentioned this thing that has this done action 2, which just simply means to say that once I run it, and then if I release the gate, if I release the envelope, then it turns off. Okay. Oh, and then I forgot to mention that we made an envelope for it, and this will allow me to, turn recording on and turn recording off as I wish. So then the one thing a couple things we have to set up peripherally, the setup parts of it, is we have to have a buffer to record into. So we set up a buffer there, and that will actually hold our audio that we recorded. Now you'll notice it's distinct from my index buffer because I want that just to hold that number, that signal that's really just counting from 0 to 1 over a certain amount of time. All right. And then we have to add it to an in group. Just a reminder, the groups have to do with not the audio so much as the order of operations of the computing. It's the computing side of things. So we just want to make sure the computer is executing all the things in this group, the indexes group, first before it executes the things in the in group. Because the ins group, even though we use audio metaphors throughout, it's going to need that index to run. You need the index here to run this buffer, right? To know which slot to write that information in, each number. All right. So we set that synth to go, set that synth to go. We can do them at the same time. That'll work. And then when we're done recording, we hit gate to 0. Okay. And you notice how it just kills it. We showed you with this query all nodes, which we don't really need. It's just something helpful. All right. So hopefully that was helpful. Hopefully you followed that. We'll be back for part 2 as to the playback side of things.